Picture a massive 20,000 TEU container ship traveling at 20 knots, suddenly throwing its engines into full reverse. That is the mechanical equivalent of what happened when the Suez Canal and the Strait of Hormuz, the twin choke points of Afro-Eurasian trade, were simultaneously compromised. Trillions of dollars in manufactured goods and raw materials were suddenly stranded between European markets and the manufacturing hubs of the Indian subcontinent and the Middle East. Global supply chains operate on immense physical momentum. When a primary path is blocked, the system does not halt. It automatically begins calculating workarounds. We are watching the death of the linear mainline shipping route and the birth of a highly fragmented, dynamic routing mesh. To understand how modern maritime logistics actually function, we must map how this new mesh operates and trace the mechanical link between these workarounds and the secondary bottlenecks they create. This map shows the baseline maritime network, a series of clean, predictable ocean highways. Look what happens when you introduce current geographic restrictions. The network transforms into an intensely dense web of overlapping, localized detours required to service the Middle East, Africa, and Asia. This visual noise represents hundreds of distinct corporate entities, all attempting to coordinate real-time physical handoffs of cargo across disjointed zones. While this sheer density prevents total economic collapse, it removes the system's buffer zones. When lanes overlap this tightly, the margins for error disappear. The network remains a fragile, improvised architecture, highly susceptible to cascading failures. Let's start with a blank mental model of the Middle East and Indian subcontinent to systematically build this new shipping architecture. The foundation of this system is the hub-and-spoke shift. Megaships are no longer penetrating deep into restricted regions. Instead, they terminate their routes entirely at peripheral, safe zone hubs. You can see this on the Far East to India mainlines. This chart tracks the CISC service departing Xingang and Qingdao. Instead of continuing toward the Red Sea, the line abruptly terminates here, at major Indian ports like Mundra and Nhava Sheva. Ports like Mundra and Nhava Sheva now serve as primary offload points for cargo originally destined for the restricted Upper Gulf. For the mainline carriers, these peripheral hubs represent the absolute mathematical limit of their geographic risk tolerance. To bridge the gap from those safe hubs into the high-risk zones, the system relies on a highly specialized logistical tier, the regional feeder operators. Entities like express feeders operate entirely differently from the mainlines. They deploy smaller, agile vessels, typically carrying between 1,600 and 2,900 TEUs, capable of navigating environments that megaships cannot. Express feeders launched the IRX-2 service, a looping circuit connecting Mundra to Red Sea ports. To service volatile zones like Djibouti, the separate JHX loop runs on irregular rolling schedules, pulsing through the network whenever berths open up. These feeder networks serve as the critical connective tissue. They are the only mechanism keeping geopolitically isolated zones attached to the global economy. Then there is the secondary geographic threat, restricted access through the Persian Gulf via the Strait of Hormuz. To bypass a maritime choke point like this, logistics networks implement a land bridge protocol. They abandon the ocean entirely. Hapag-Lloyd's diversion strategy prematurely discharges ocean freight at Corsican. From the dock, cargo transfers directly to road feeder services. Trucks then haul containers overland, cutting across the UAE to reach final destinations in Sharjah, Jebel Ali, and Dammam. This multimodal bypass successfully mitigates maritime risk, but it does so by converting massive, consolidated ocean volumes into intense, uncalibrated highway traffic. When you force all these simultaneous workarounds to converge on a single node, you test the physical limits of a port. This is exactly what happened at the port of Jeddah. When a terminal hits 90% yard density, it faces paralysis. The physical space required to simply shuffle and sort containers vanishes. This extreme density directly provoked a cascading drop in efficiency, driving gantry crane productivity down by 25%. Once the terminal paralyzes, the landside infrastructure fails next. At Jeddah, 5 to 6 kilometer queues of trucks became trapped outside the port gates. This breaks the rigid digital infrastructure governing the port. The FASA gate pass system offers no concessions when physical trucks miss their tightly scheduled digital slots due to a traffic queue. The logistical cure of bypassing the primary choke points concentrated too much volume into an uncalibrated node. The industry effectively engineered a localized operational collapse. The global shipping network is not a static map of trade lanes. It is a real-time risk algorithm, constantly recalculating its tolerances. We can see this in how corporate tolerances diverge. Hapag-Lloyd responded to the congestion trap at Jeddah by suspending bookings to the port entirely. Meanwhile, Maersk executed an opposing strategic gambit, pushing their AE-15 service back through the highly contested Suez Canal. The calculus driving this decision is brutal. The operational costs, delays, and paralysis of the Jeddah workaround simply became too high to sustain. Carriers are now directly weighing the geopolitical threat of a primary artery against the guaranteed operational collapse of a secondary hub. Modern supply chain resilience is not about avoiding risk. It is the perpetual, systemic arbitrage of choosing exactly which type of disaster you are best equipped to survive.